Hello and welcome to the physics admissions talk for the 2021 Oxford Open Days. So let me start by apologising that in contrast to a normal open day, this talk is being given online. Therefore, it may lose some of the immediacy, the ability to respond to an audience, the ability to pick up cues from the audience that one might normally get in an in-person talk. So this talk is primarily about physics admissions to Oxford for admission in October 2022 or deferred entry in October 2023. So these are candidate people who will be applying to Oxford in December of this year, in December 2021. And I'm Joseph Conlon. I'm the current undergraduate admissions coordinator for the Department of Physics. Right, so let me just give you the overview of what this talk is going to be. It's primarily a talk about admissions. So I will say a little bit about the course itself, but only a little. The talk is primarily about how admissions is structured and what are the various steps in admissions. I'll say something about the department and the colleges, the difference between what the department does in Oxford and what the colleges do. I'll say something about the physics aptitude test, the test that we require all undergraduate applicants to sit, and the results of which are kind of very important in our admissions process. I'll say something about the qualifications required and the level of our standard offer. About the other aspects of your UCAS application, so your personal statement, the reference from the school, and then how we shortlist and how the interviews will be structured. And then finally, I'll say about when decisions would be expected to. So I will also apologise if in some cases I'm not able to give full answers. The effect of the pandemic means that certain things are still ongoing. This year is another novel year, in particular because for this year, those of you who are applying this year will have not, for the first time, have not taken GCSEs in the normal fashion, as basically external exams that are invigilated. And it is still a process to basically work out exactly how we should treat these in terms of thinking about to interpret the GCSE results you have. Okay, so let me say something about our courses. So physics at Oxford, we take approximately 200 undergraduates a year. That includes both physics and philosophy. So these are the two main courses offered. Physics and philosophy. They exist in both 4-year and 3-year versions, but we recommend, the thing is, what you should really do is you should apply for the 4-year course. You should apply for the 4-year course, and then having applied for the 4-year course, you can graduate after 3 years if you wish with a BA, but apply for the 4-year course, and then if you want to graduate after 3 years, you can. If you apply for physics and philosophy, you will be assessed by both the physics tutors and the philosophy tutors. If it's the case that the physics tutors think that you're acceptable, you're good enough as a candidate, but the philosophy tutors don't, then a physics and philosophy candidate can also receive an offer for just physics rather than for physics and philosophy. I should also warn at this point against people who think that applying for physics or philosophy is in some way an easy option, or that it's 40% physics and 40% philosophy. It's actually a rather tough course. Rather than being 40% physics and 40% philosophy, it's probably more accurate to describe it as 60% physics and 60% philosophy. Another course I should mention is the MMath Phys. So this exists as a 4th-year option within the MPhys, so you can transfer from the MPhys into the MMath Phys. The MMath Phys is a 4th year, which is basically particularly theoretical for those students who are particularly theoretically minded. But you can't apply for it at the start. Right, so now let me say something about admissions. Okay, so the first thing which you probably know, but let me just say, is that you cannot, many students who are considering us will also be considering Cambridge. You cannot apply to both Oxford and Cambridge in the same year. So you can either apply for Oxford for physics, or you apply to Cambridge natural sciences. The number of applicants we receive to study physics at Oxford has been going up each year. Last year we had about 1,800 applicants. We expect the amount this year to be at least as many, so there are probably going to be 1,800, 1,900 or something applicants in total for physics at Oxford, with there being about 200 places in total. And so that original number will be shortlisted down to about 500 candidates who we will interview, and then we will make around 200 offers. If you're applying to Oxford or Cambridge, you have to hit an earlier UCAS deadline of the 15th of October 2021. And you also need to register for the PAT by this date. The PAT is the Physics Aptitude test, and it will be expected to be sat on the 3rd of November 2021. It is your responsibility to register for the PAT, and you must register for the PAT in order to be considered by us. So by the 15th of October, you need to have submitted your UCAS application and to have registered for the PAT test. You then sit the PAT test in early November. We mark it, and as I'll discuss later, based on the results in your PAT and the other aspects of your application, we will decide whether or not to invite you for interview. And these interviews are going to be in the middle of mid-December 2021. So this year, the interviews are going to be online, as they were last year. So this means that rather than travelling to Oxford for the interviews, you would have the interviews either at home or in your school. Following the interviews, we make a decision as to which candidates we're going to offer places to, and then all candidates for Oxford are informed on the same day, which will be in early or mid-January 2022 on a date that is set by the university. Let me say something about how Oxford is structured. So as a physics student at Oxford, there are two parts. There's the physics department and your college. And different parts of the teaching are divided up in different ways. The department is where you would have lectures, it's where you would have your practical labs. So the department has the large lecture theatres, which hopefully you will be able to be going along to in person by the time you arrive. It also has the practical labs where you would do your practicals. In the colleges, you would have tutorials. So these are typically the small group teaching where maybe 2 or 3 students will meet with one tutor to go through the problem sheets. The lecturer for your course will set the problem sheets, and then you'll go through the problem sheets with your tutor. You will live in your college. You will develop friends in your college. You will develop very close friends in your college, and many people indeed end up meeting their spouse in their college. So the college is really like, it's where you live. It's your home for the next three or 4 years. A lot of your social life will be based around the college. Not all. There are plenty of university societies. The department is where you have the large group teaching. So this division between the kind of the college and the department is one that is really central to how Oxford are structured. And in terms of physics and philosophy, not all colleges take physics and philosophy, offer places for physics and philosophy. Colleges which typically offer 2 or more places are Balliol, Brasenose, Oriel and Merton. You will have seen it, if you visited Oxford before, or if you look around Oxford, or if you read about Oxford, you'll see that colleges can differ quite a bit in terms of their architecture. So even though maybe your stereotypical image of an Oxford college is that it's got buildings that are several hundred years old, fancy manicured green lawns, and sort of old halls where people can sometimes wear gowns to. There are also colleges that are far more modern and have very striking modern architecture. Colleges that are located in different places. Some are close to the physics department. Some are more in the centre of town. Some are more on the outskirts. So when you apply, you may want to kind of choose a college that you feel that you're more attracted to, maybe by its architecture, its age, its location. Or you may not want to. You may want to leave it random, in which case you can submit an open application which means that your application will then be automatically assigned to an initial college. I would say, though, that colleges are more similar than different. That the structure of the teaching means that the experience between different colleges is really going to be more relatively similar compared to, say, the experience between Oxford and a different university. And it's also true that even if you've got students have an idea of what sort of college they might like, normally whichever college a student ends up at, they will quickly, within a few weeks, decide that this is actually the best college in Oxford. Typically in a college, I should say also, there will be between 5 and 10 physics students in a year. So that will be your sort of immediate year group within the college, who you will attend tutorials with, and you will help each other out when you get stuck on problem sheets. Right, let me now talk about the physics aptitude test. So the physics aptitude test, or PAT, as it's more commonly known, is the test we require all our physics undergraduate applicants to sit, no exceptions. You have to take the PAT to be considered for admission. Last year, because of COVID, there were, if you recall, there were sort of various lockdowns in place. So there were some students last year who couldn't take the PAT because of COVID reasons. In that case, what happened is we arranged a backup PAT, and such students sat the PAT a couple of weeks later. It's a bit early now to say you should be able to foresee exactly what the COVID situation will be in autumn of 2021. But if COVID became a kind of, if there was another sort of serious resurgence of COVID and people were not able to take the PAT because of COVID, then we would anticipate, without being absolutely certain at this point, doing something similar again. So there are lots of PAT papers online. You can find all the past papers on our own website. If you look around the internet, you will also find various websites where people have solved quite a number of the questions. You'll also find sort of student discussion groups where people who are preparing for the test will work through the problems. There's also some material from our own course, the Preparing for the PAT course, which will be made available. So there are all these sort of online resources that are available for you to learn about the PAT questions, learn about the practice doing the past papers, and practice getting good at doing it. So normally you will sit this test in your own school, and it's 2 hours. It covers both physics and maths. Calculators have been permitted for the last few years. Most calculators are permitted, but you're not allowed calculators that can do the more sort of fancy kinds of symbolic manipulation or sort of integrals for you, and so on. In terms of the preparing for it, I strongly recommend you look at the past papers. I mean, what you will see, as particularly on the next slide, so the average mark, PAT is quite a hard exam. The average mark for the PAT test is much lower than people will be typically accustomed to getting in their A-level papers. And the way you really need to practice it to do well at it. Okay, so let me go to the next slide. So this shows you the marks that people from last year's PAT, the marks that people got on the PAT, the distribution of the PAT scores, and then how people subsequently got on. So what you can see is, so the blue peaks are basically everyone. The orange part is people who got invited for interview, and the black is people who got an offer. And so what you can see is, first of all, this is quite a competitive process. There is roughly one place available for every 9 candidates who apply. Secondly, you will see that doing well on the PAT is a very good predictor of both getting an interview and then subsequently getting an offer. So if you looking towards the right of the diagram, you will see the higher scores on the PAT, and how above a score of roughly about I think that's 68% or something. Basically everyone who got that score got invited to interview. And then as you go up, you see the people who've got the higher scores, the majority of them, but not all, were subsequently made offers to study at Oxford. You'll also see, if you look at the test as a whole, you can see that the peak mark is around 50%. So this is quite a tough exam. It's hard questions on relatively simple topics, relatively simple material, but the questions are designed to be hard. And you will also see that there is not a single cutoff score to determine whether or not a candidate gets shortlisted. So you can see we always look at people's individual circumstances. So you can see that there's a trail of kind of orange and black going down to lower marks. Remember, black are the offers and orange are the interviews. So you can see that there's basically, there's a threshold above which pretty much everyone gets interviewed, and then below that there is still a chance of being invited to interview as we consider your contextual data and all the other information in the application. But this is a sign that the doing well on the PAT is pretty much a precondition for being interviewed. Right, so we're interested in, we want good physicists, people who are good at physics and good at maths. And so there are not formal requirements on your GCSEs. There's no minimum number of A stars, for example, that you're required to have. But it is true that kind of most successful candidates have between 4 and 12 A stars at GCSE. Lots of candidates are academic all-rounders who's are not just excellent at physics and maths. They're excellent at all subjects, and they've also got a strong work ethic, and they get lots and lots of A stars. There are also candidates who are more kind of one-dimensional. So every year there are candidates who are extremely good at physics and maths, but maybe less good at English and French. Who will still get offers even though they've got fewer number of A stars at GCSEs. The standard offer we make is A star AA. So this is the A star AA in your A levels, and your A level subjects must include physics and mathematics, and the A star must be in either physics or mathematics or further mathematics. Now, I should note, even though this is our standard offer, it's not intended that this is not, we're saying what you should aim for, because the vast majority of Oxford offer holders will attain higher A-level grades than this. Generally, it's in the Oxford admissions process, at least in the Oxford physics admissions process, it's true. It's the PAT test and the interviews are the harder part of the process than attaining the standard offer for people who are applying to Oxford. People who want to be good at physics need to be good at maths. And so we recommend taking further maths if it's possible. It's not a required subject. We know that not all schools offer further maths. There are some candidates who are not able to take further maths. And every year, many people are accepted without it. But we do clearly, if you've got the chance to take further maths, we kind of clearly recommend taking it. And it would be reasonable, if you haven't taken further maths and you had the choice to take further maths, it would be reasonable to be asked to interview why you didn't take further maths. And what's certainly true is that if you're applying for physics here, you should be confident that if you had the chance to do further maths, you'd have enjoyed it. It's a subject you'd have enjoyed, and you've done well at. Because for people who haven't got further maths, then the material gets covered in the first few weeks of the course, but obviously that gets covered rather fast. And it's just generally true in physics. The more maths you know, the better. So if you have no chance for your school to take further maths, you see the number of applicants who will sort of who will self-teach a part of the course, or will just try and learn some of it because they're interested in it. Now, talking to applicants, it often seems that one of the parts of the application that people most agonise about is the personal statement. What should you put in this few hundred words to describe you to the tutors who are reading your application? So the first thing I really want to say about this is that it is true that the personal statement, at least applying to Oxford Physics, the personal statement is the least important part of your application. We've read many personal statements where people talk about their subscription to New Scientist, the books by Brian Cox they've read. And the thing that is going to, will most make you stand out is, as I've said, is doing something like that very well on the pad, rather than reading popular science books. That said, the personal statement is not nothing. We're interested in your motivation for reading physics. I mean, Oxford, as a course, it's an academically intensive course. You'll be expected to work hard on there. Providing evidence that you're capable of working hard in the way that's required to succeed in the Oxford Physics course is a good sign. People often put the other achievements they've done. Obviously, we're a physics course, we're an academic course. We're not intrinsically interested in your music or your rugby or your dance, but these do provide good evidence of an ability to work hard and consistently at something which is difficult. I should also say that if you feel the desire to put something in your personal statement about how you've learned some advanced piece of physics, or you've done something else which is extremely impressive, just be prepared to be asked about it at interview, and make sure that you really have done it. However, I will also say that it is not at all uncommon for in an interview at Oxford to have no reference at all to your personal statement. That the interviewer will ask you nothing at all about your personal statement. So this is why I say, do not over-agonize about it. I know it's hard to write, but at least in terms of your application to Oxford Physics, it is the least important part. We also have the reference from the school, which will be telling us, hopefully more frankly, about your school's view of you. Okay, so having applied and having sat the PAT test, the next stage is shortlisting, where we shortlist the roughly 1,800 applicants down to 500 that we will interview. So as I said, the PAT score is the most important element in this, but it's not decisive. If you look at the distribution of PAT scores, you'll see there are certainly people with higher PAT scores who do not get shortlisted or offered, and there are people with lower PAT scores who do get shortlisted. So in working this out, we consider your contextual data. This is the information about where you've gone to school, where you live. I mean, basically all the kind of the aspects that are about you, and to try and get the fullest picture of you as an individual. So all applicants and their circumstances are considered individually. One of the things about contextual data which has applied in previous years, but I cannot say at this point exactly what form it will take for this application round, involves GCSEs. So in previous application rounds, we've looked at your GCSE grades and looked at how they compare to applicants from other quote-unquote similar schools. Now, because the GCSE grades that you have from summer 2020 were affected by the pandemic, because they were ultimately teacher assessed in Origin rather than through sitting external exams, this is a much more subtle process this year, because different schools, different teachers may have applied different policies in allocating GCSE grades. So this is work in progress at the university level in Oxford to determine the exact form of contextual data that will be used in the December 2021 admissions round. However, the general principle that we are applying, that Oxford Physics is applying, is that given that there is the wider variety of personal circumstances that have applied since March 2020, given the disruption to your schooling that has been experienced, to increase the focus on individual circumstances when we are considering candidates. And what you can see is from last year, which was also kind of a COVID affected year, is you will see that there was a kind of effectively a threshold where if people scored above about roughly 67, 68, 69 on the PAT, that was strong enough that essentially all such candidates were interviewed. But there's quite a tail below that where contextual data and personal circumstances were used to decide whether or not to invite candidates for interview. Right, now let me now move to talk about the interviews. So the interviews will take place in mid-December, and they will all be online in 2021. So to ensure that things are as fair as possible, and we practice what's called reallocation. So what this means is that all colleges will interview 2.5 applicants per place. So that if one college has like a very large number of strong applicants in 1 year, and another college has less strong applicants, then the college will be reallocated at the interview stage. So, for example, say Balliol had lots of very strong applicants, and Brasenose College had less. Then what might happen is some of these applicants might be reassigned to Brasenose at the point of interview. And this is to ensure there's an equal number of applicants per place at each college, so that applicants are not disadvantaged by applying to a college that has a particularly large number of good applicants in 1 year. So for a physics candidate, 2 interviews will be with their primary college, and 1 interview would be with a second college. So this is the same for all applicants. Everyone has 2 interviews at the first college and 1 interview at the second college, so everyone will have three interviews. It can vary a little bit in terms of the 2 interviews. Some colleges will do the 2 interviews as 1 physics interview and 1 maths interview. Others will mix up physics and maths in both those interviews, but the general principle is that everyone will have 2 physics interviews with the first college and 1 interview with a second college, and the second college is more or less randomly allocated. Physics and philosophy candidates will in addition have philosophy interviews. So in principle, they could have up to 6 interviews, because they could have up to 2 philosophy interviews with their first college in addition to the physics interviews, and possibly a philosophy interview at the second college as well. So in principle, a physics and philosophy candidate could have up to 6 interviews. Oxford physics interviews are primarily academic in nature. This means that you'll mostly be asked physics and maths questions. You may be asked kind of an icebreaker question at the start, but what the interviewers are interested in is your physics and maths ability, and so the questions, so sort of any sort of social questions at the start are really just to kind of try and set you at ease and just sort of settle you into the interview. So your first college is your primary college, and most communication will come via the primary college. And if you have queries or questions, it's the primary college to which you should direct your questions. So as a consequence of COVID, it's been decided at the university level that all interviews for all subjects are going to be online in December 2021. So candidates you'll take your interviews either from your home or your school through, probably through Microsoft Teams, through an online link to the college. Normally, in an interviewer, there will be 2 interviewers, and within each interviewer, so there'll be 1 applicant and then 2 interviewers. And the format's intended to allow candidates, even online, to show their physics and maths thought processes. So it's possible different colleges might use slightly different methods in terms of how they do that. Some will use shared virtual whiteboards. Others may use slightly different processes, but whatever the format is, it's designed to give candidates the best opportunity to show their physics and maths thought processes to the interviewers. I mean, the interviewers are interested in how you think. They're interested in giving you a chance to kind of show your physics abilities, show your maths abilities, and show them how you think, how you work out an unfamiliar problem that you haven't seen before. That isn't just a straight textbook problem. How you respond to hints when the interviewers give it. It's quite normal in interviews to be stuck at some point. That's completely standard. But the interviewers are interested in seeing how you respond when you get stuck, how you respond to a hint, how you try and think your way out, or think your way through the problem when you get stuck. And I think, so the expectation is, I think it's not completely firm at this point, but the expectation is that candidates who receive an offer from Oxford will be then given a chance to visit Oxford in person after receiving the offer. So to visit the college that's made them an offer and to visit Oxford itself. Right, so one thing that, naturally you are wondering is kind of, when people are interviewing, when people are making decisions, what are tutors looking for? So there's no magic answer here, nor are there any kind of secret codes. Yeah, we're a physics department, and at the end it comes down to we're looking for the people who we think are going to become the best physicists. So what's feeding into this? We've got the physics admissions test, the performance in the test. We've got the interviews. We've asked you physics and maths questions. You'll have 3 interviews, so even if one interview goes dreadfully, there's two other interviews to give it kind of another independent look on you. So we're looking at how you solve problems, your ability to kind of think independently when you're stuck, your general kind of physics and interest into physics and the maths that is kind of necessary for it. Your ability, in the sort of environment of an interview to, when you get stuck, how you can work out where you need to go in the problem, what pieces of information you need. And of course, when we're looking at, because it's an academic university, we will also be looking at your kind of previous academic record, like your GCSEs, your predicted A-level grades, what your school thinks of you, and also your personal statement. As I said earlier, there's no score on the PAT that will guarantee a place. There's no number of A stars at GCSEs or anything like that will guarantee a place. I mean, every applicant is considered in the whole. We're looking at all the different bits of information that we have at you, and then we're trying to decide about people, make a decision about people who have the best, in our view, potential and ability to study physics. And to study physics in the particular Oxford system, the system of departments, colleges, tutorials. Okay, so let's just give an example of an interview question. So this is a question that has been used in the past. So you've got a puck, as in an ice hockey puck, that's moving on the surface of an ice rink. So all friction can be neglected. There's a smooth bump and a smooth dip. And the question is, does it move from A to B in a shorter time in diagram 1, diagram 2, or there's no difference? So now how would a typical interview go with something like this? So a candidate might see this and they might draw the pictures, copy it down to think about it. Then they might start talking. They might start trying to draw up equations. The interviewer might kind of prompt them in the direction of thinking about energy. So we might think about conservation of energy. And if a candidate mentions conservation of energy, then they might be prompted to kind of encourage in that thing. And think about the kinetic energy and the gravitational potential energy. And so what happens when you go down up a dip? So what happens when you go up a bump, or what happens when you go down a dip? Different candidates may approach this in different ways. Some people may be more keen to write down equations. Another way is to think about extreme limits. This is often a good idea in physics problems. So if you'll ask which one takes a shorter time, you might want to think about, well, what happens as you make the bump higher and higher, or the dip lower and lower. So, for example, that might be able to convince your intuition that if you make the bump higher and higher, you'll get to a point where the puck will just slow down. So it's basically going at no speed at all on the top of the bump, which obviously means it will take a very long time. Whereas if you have the dip and you make the dip bigger and bigger, you might realize it will kind of whoosh through the dip, going faster and faster. That's the more intuitive way of thinking about this. Another way of thinking about is in terms of conservation of energy, and say that as you go down a dip, the gravitational potential energy converts to kinetic energy, so the puck moves faster. Whereas in the first case, you've basically got a cost in energy, and so you've got to lose kinetic energy to increase the gravitational potential energy. One thing I should also say here is that, interview questions are not designed to trip people up. They're not designed to be, like sort of magic tricks or anything. and the right way to kind of think about them, even though it's natural to be nervous in an interview, is to be thinking about you're discussing some aspect of physics or maths. You're applying for physics. You are a keen young physicist, and to discuss some aspect of physics and maths with another keen physicist who's more experienced than you. And so if you think of this as a shared discussion on physics, then I think that is the right approach to interview questions. Now, that you like doing physics, and this is a chance to talk about some fascinating problems with someone else who also likes doing physics. Now, and the questions really are, I mean, yeah, there's a mystique about them. There's all these sorts of stories about Oxford interviews or Cambridge interviews that you can find online. But really, there's no kind of magic to them. You'll be asked physics and maths questions, and what the interview questions are trying to gauge is your ability to think on your feet and solve physics and maths questions. And the interviewers know it's natural for you to be nervous. It can be natural for you to be very nervous, and they will always try and do their best to set you at ease. Okay, so what happens at the end of the interviews is everyone's had 3 interviews. Everyone's got a PAT score, and everyone's got their UCAS form with their personal statement and the reference from the school. So at the end of the interview period, the decisions are made on who to make offers to. So there's a central physics database which contains all information on all candidates, because we all want the best candidates to get offers at Oxford. Not to be sort of just trying to pick people who have applied to an individual college. So to ensure that the best people from all applicants get offers, there's a single database, and this has got all the information on all the candidates. So this has got their PAT score, it's got all their interview scores, and it's got the UCAS form of every candidate. And all the tutors from all the colleges have access to this database. They can click on the UCAS form of anyone. And the idea is that everyone's got a full view of the application field. And so when making decisions, the aim is that the best candidates will get an offer. There's a central meeting of all the physics tutors, where all the tutors get together, normally in a large lecture theatre or online, possibly due to COVID. And in this meeting, people then discuss the candidates and try and ensure that the best candidates will get a place. And just to illustrate what this means, so last year in 2020, so of the 200 offers that were made, 15 of those offers were with a college that had not interviewed the candidate at all. So the candidate receives an offer at a college that hasn't interviewed them for their first interview and hasn't interviewed them in their second interview. And this is because there's basically this central database, and the colleges are looking across the whole field of candidates to try and get the best candidates, whether or not they've actually interviewed them themselves. So then the decision will be made as to which candidates get made an offer. That decision is done pretty soon after it was within a couple of days of the last interviews. But then the notifications are all sent out by the university in January 2022. The university will has a definite date at which all candidates will be notified. Right, so as I said, the offers. So offers come in several forms. They can either be, first of all, open offers or maybe kind of regular offers. So a regular offer is with a particular college. And an offer with a particular college, it would most often come from the primary college, which the college has given which is the kind of the quote unquote first choice college, or the college where someone has had 2 interviews. They also come from the second choice college, the college where they've had 1 interview. And as I said, last year there were 15 offers 15 offers with a college which has not interviewed the candidate at all. The other type of offer is an open offer. So an open offer guarantees a place in Oxford, but it does not specify a college. And this is because every year there's a certain number of withdrawals or people who don't make their offer. So people who decide they're actually going to accept an offer in America, and so they're going to decline their offer in Oxford. So there's always a certain number of places that will become vacant. And the open offers are designed to cover this. So a candidate who receives an open offer does not have the college specified, but then the college will be determined in August once the A-level results have come out. As I said, normally offers are conditional on examination results. Though if someone has already attained the results, then this would normally be waived. So, for example, if someone is a post A-level candidate and they've already made the standard offer, they would not have to re-achieve the standard offer. And the standard offer is a minimum of A-star AA, which includes at least a grade A in physics and maths, and as an A-star in either physics or maths or further maths. And there's also a requirement that you pass the practical component of any science subject that you are using to make your offer. So, for example, if your A-levels are maths, physics and chemistry, then you have to pass the practical component in both physics and chemistry. For other countries, there are standard offers also, and these should be available on the departmental and university website, the form of the standard offer for systems other than A-levels. So feedback on admissions decisions all comes via colleges, not the physics department. So it's the colleges that make people offers, not strictly the department. So any queries, feedback requests, anything of that nature should go via the colleges, and particularly the primary college, rather than the physics department. In terms of general feedback, so every year we publish a physics admissions report, which contains general information and statistics on the admissions process in the previous round. The figure I showed you earlier about with the PAT score and how PAT scores then turned into either interviews or offers comes from last year's physics admissions report. And then applicants can also request individual feedback, including their own PAT score from their primary college. Some colleges will send this out automatically, but others will provide it on request if a candidate writes it. Now, I'm sure many of you also have questions you would like to ask. So because this is an online talk, recorded in advance, I can't answer these questions now. So sorry about that. But we have Q&A sessions at the open day. So either through one of the text runs, or we hope also through a live Q&A session. If you please submit any questions you've got about the admissions process, and then we will do our best to answer them. Okay, so that is the end of the talk. So thank you very much for listening. I hope you found it useful. And there are any questions you've got that you would like to ask, then please do so via the open day Q&A rooms.